Hi everyone, this is Dr. V.S. Nishok from EC Department, SNS College of Technology. Here we have gathered to discuss the topic PN Junction Diode from the subject Fundamentals of Electrical and Electronics Engineering. So this is the outline of this video. It starts with challenges with diode and then PN junction behavior, key analogies of PN junction, and finally its practical application. So what is the challenges with diode? So in today's world, so everywhere in each electronic circuits like rectifiers, solar cell, LED and transistors, wherever we are using, we will be need of the diode, PN junction diode. So if any fault in manufacturing or any overheating occurs, the results may be varied and disasters may happen. So in theoretical or practical study, we will come across the word 0.7 volts often without knowing the why it happens, why it coming. So coming to the PN junction behavior. So PN junction behaves that when connected with the external bias in forward bias condition, it will allows the current to flow through it, and when it is reverse biased condition, no current will flow through it. So this is the primary behavior. And coming to the secondary behavior, due to any overheat or any temperature increase, the parameters like current and voltage will vary drastically. So that is the main behaviors of this PN junction diode. So coming to the key analogies of PN junction diode, it starts with diffusion and recombination. So from the P-type material, the holes, and from the N-type material, the electrons starts to combine near the PN junction. So this will combine, both will combine and leaves the immovable ions near the PN junction, which creates the depletion region. So that is the next analogy, depletion region. So this depletion region will create a electrical field with the barrier voltage of 0.7, so which does not allow any further diffusion. So coming to the barrier potential, so this will stop, this 0.7 volt of barrier voltage will stop the flow of electrons further. So this is the time for activity. So coming to the forward bias behavior, when we are connecting the PN junction diode in the forward bias condition, that is positive of the supply will connected to the P-type material and negative of the supply connected to the N-type material, which when applying the voltage above the 0.7 volts, which makes the current to flow through the PN junction, which overcomes the barrier voltage. So that is applicable here in the forward bias condition. So coming to the reverse bias behavior. So in the reverse bias, the negative of the supply will connected to the P-type material and positive of the supply is connected to the N-type material in the reverse condition. So due to this condition, so this negative will attract the holes in the P-type material and this positive supply will attract the electrons in the P-type, N-type material. So because of this, the depletion region in between the P and N junction will increase its width. So this is why we cannot have any current flow in this reverse bias condition of the PN junction diode. And coming to the VI characteristics, so this is nothing but voltage and current characteristics of the PN junction diode, which shows in the forward bias condition there will be a linear increase in the current after the 0.7 voltage, and then coming to the reverse bias, so there will be some micro level increase in the current if we increase the voltage. So this is the practical applications. It starts with rectification and protection diodes and signal or power diodes or temperature sensors. Let us summarize this video with the topics that we have discussed from first slide. So we will started discussing the understanding the needs and challenges, and we are moving to the PN junction behavior, general behavior, and we have started seeing the diffusion and depletion region, and then we will seen the barrier potential, and coming to the forward and reverse bias operation, and we have seen the practical applications. So this is the time for assessment. The potential barrier in a silicon PN junction diode is approximately 0.7 volts. So in forward bias condition, the width of the depletion region will decrease. Only in the reverse bias condition, the width of the depletion region will increase. So this is the reference material where we have obtained a lot of information about the PN junction diode. So thank you all for joining this video. We can join in the next video.